Hello, 6 applications, electromagnetic induction. Last one, hopefully. So, mine detectors, metal detectors. How do they work? Well, they're used. What do they look like? They look like this. Notice there's a coil. Usually there's two coils, an induction coil and a feedback coil, or the one coil might be used for both purposes. And basically what they're doing is producing a current in a piece of metal. So they induce a current in a piece of metal, and then that current induces a magnetic field, which is then sensed by the coil and tells you that there's a piece of metal there. They're used in airports and buildings where you have to walk through. They come in all shapes and sizes. Don't see too many people using them in Australia, but they're big in Europe and England, where you've got a longer history of buried treasures and lost coins and Roman coins and things that are valuable, gold, stuff like that. Whereas in Australia we don't have a long history of that. So you see, in England you see people walking over paddocks where Roman artifacts, for example, had been found, and every now and again someone will find a buried hoard of coins that's worth thousands and thousands of dollars. So you can buy a book about it, and you can treasure hunt for fun and profit with your metal detector. Oh, well, what's this? Whole lot of words? Oh, that's right. This is about pulse induction, which are airport metal detectors, the ones that you walk through. Most of us have been on a flight nowadays, and if you haven't, you will soon, one day. And so you walk through a gate, and they tell you if there's metal or not. And how does that work? Well, again, it's basically two coils, or a coil of wire, which is a transmitter but also a receiver, and it sends out short bursts. So you can pause this and read all this if you like. I'm going to talk very briefly about it. Sends out a pulse in the coil, and that generates a brief magnetic field, and when the pulse ends, the magnetic field reverses and collapses, and therefore it only lasts for milliseconds, and then another pulse is sent out, and the process is repeated about 100 times a second, so very quickly. That's why you can walk through them fairly quickly. Now if there's a metal object there, the pulse creates a magnetic field in the object. It induces a current in the metal object, and that produces a magnetic field. Those magnetic fields interact, and therefore when you get you get what's called a reflected pulse, and it's not the same as if there's no metal object in there. And so the machine, the PI metal detector, detects basically the missing magnetic field because of the interaction of the two magnetic fields. Now there's a link there on how stuff works that shows you how it works. Fairly straightforward. What else? Yeah, this is a mine detector being towed by a helicopter. Pretty dangerous to tow something like that from a helicopter, but a mine detector, so looking for mines in what are they called? Ocean channels, shipping channels, that's it. And so how they do it, they tow it behind. If there's a mine, you can have a cutter that cuts the mine, or you can have, more than likely nowadays, this little hydrofoil sled is full of electronics, because most mines are not, in the Second World War the mines were fairly simple. They detected a magnetic field due to a big lump of metal going over them, and they were either on the bottom and they released themselves and came up and exploded, or they were waiting for the ship to come close. Very few of them were actually needed to be touched by the ship to blow up, but nowadays mines are much more clever, and so they can be very stealthy, and so now the sled has all these countermeasures to try and determine where the mine is. But even simple basic mines are still dangerous to ships and have to be got rid of. And here's a pair of them in tandem. Pretty impressive sight, mine sweeping. And that's what the sled looks like, and that's the tray full of countermeasures. And there it is, lifts up on a hydrofoil, so there's less resistance, and it can travel larger distances fairly quickly. Big helicopter though, big helicopter. Flow meters is a way of using Faraday's law of magnetic induction to measure the rate of flow in a liquid. Basically, if you've got a hot gas or anything that can conduct electricity, doesn't have to be hot. You have a couple of coils, and then you have a secondary coil, and you generate, because basically you have a charge, electric field induced by magnetic field, and you have a voltage. So it's a way of measuring the flow. Yeah, and they can be. The advantage of these guys is that if you have an existing pipe, you can just strap this onto a pipe and do. So if you're testing somewhere, you don't have to have meters everywhere. You can just use a few of these to test wherever you're interested in what the flow rates are, and then they have a readout. So fairly good. Induction microphones. So microphones work effectively the opposite to speakers. There's an old one. They used to be big chunky things because they relied on lots of carbon grains to vibrate. Basically what they're working on is you have your magnet, alright, or your magnet is here. So you, what's that? No, the magnet's here. There's the coil. This is the outer case. Okay, and then you have a diaphragm. And so sound waves come across here, cause the diaphragm to move, which causes the coil to move, and because the coil is therefore experiencing a changing magnetic field, you get a current coming out, which is then sent to the amplifier. Now that's exactly the opposite to a speaker, isn't it? But the same principles, but this is electromagnetic induction. And they get more complicated. You have your diaphragm, you have your little magnet, and the more money you spend, the more complicated they're supposed to be. And musicians are always trying to get the perfect microphone. Yeah, but they all work basically in the same way. Seismometers, so measuring earthquakes. There's one on the moon. We left one up there, so measure any earthquakes and minor tremors. And the moon is pretty quiet, but it does undergo some thermal earthquakey things, but only on a very small scale relative to Earth. But that's still up there. This is what they look like. Usually they're put on a big bed of concrete, usually buried, and basically it's a coil. It's like a microphone, but it's fixed to the Earth, and so any vibration in the Earth causes the coil to move, which generates electricity, which generates the current, which is the earthquake monitoring. Down pits, and so these are actually scattered around Australia. Farmers are paid, or landowners are paid money to have one of these on their property because Geoscience Australia, I think, they periodically have to go out and inspect them, and so the farmers get paid to put them on their properties. But they're scattered all over the place and are part of the network now. They're also plopped onto the bottom of the ocean because we need to know about earthquakes happening about there, and the nearer a seismometer is to the earthquake, the quicker the signal or the earthquake is detected. So you want to have these things all over the surface of the Earth, so you don't get surprised by an earthquake, and therefore you don't get surprised by a tsunami that's generated by the earthquake. So what do geophysicists do? Of course, they wander around with poles hanging off them. Again, they're using electromagnetic induction sometimes to generate a signal. So there's a variety of ways of looking at what's underneath the Earth, and electromagnetic induction is one of those ways, particularly if you're looking for metal pipes or plumbing, but also if you're looking for metal deposits. Sometimes people can lay communication cables through fields and things, and then all the paperwork gets lost and no one knows where it is, and so geophysicists have to go around and find it rather than dig up the whole field. And same here, rather than digging up the whole road, this guy's finding it. So they carry poles around a lot, geophysicists, but really clever ones get to ride a quad. Now they also send things down into drill holes. These are some very expensive measuring devices to go down and measure the relates to the magnetic field of the rocks, and so they send out signals, and they're looking for ore deposits, which of course contain metal or metal minerals. Interestingly, a use of electromagnetic induction that's really cutting edge is Formula 1 electric racing cars, which people are thinking about going towards. And that's where you can have a car that doesn't have an electric engine, doesn't have a petrol engine. It runs purely on an electric engine, and it has a battery, and it looks much like a Formula 1 car. And I'll blow that up. So it's got a battery, it's got exactly the same suspension, it's got exactly the same drag. The battery's built into it so that it distributes all that weight around it. But the interesting thing is, generally speaking, the batteries wouldn't last long enough in a race, and so what they are thinking of doing is having wireless charging, where you have charging mats embedded into the racing line, and the car just has to drive over these areas to recharge their batteries. That's a pretty interesting idea. And so yeah, be interesting to see if it goes ahead. Certainly people are giving it some serious thought. They'd be a bit quieter than the ones that they have now. Other uses, bolt heaters. So you can use induction if you're working on big heavy equipment like dozers and mining equipment, and it all gets rusted up and seized up and dirty. It's almost impossible to undo some bolts, and they use bolt heaters to cause the bolt to get hot, and therefore it expands, and therefore it gets loosened. And there's a little video on the OneNote that shows how that works. Some people just use oxyacetylene, but you can buy these bolt heaters. Body panel removers, so heating up the panel. Basically it's heating up the like you have a panel and then you have a plastic guard, like to stop getting dings from people's doors and things, and that's stuck on with a glue, and that glue is heat setting. And so if you heat up the panel, that heats up the glue, and you can just peel off the panel without damaging it, and then put it back on when you've painted the car or whatever. Sealing machines. Lots of plastic bags are sealed, and they often use induction to heat the pieces of metal. So now you can do all these questions, and you've probably already started them already, hopefully. And that will be everything you need to know about electromagnetic induction. See ya.